quick question I had on why there are so many more males affected by color blindness than females. So there's approximately 8% of the population of males are colorblind. Okay, and then I'm going to kind of show you how we would arrive to the percentage of females who are colorblind, and it's way less than 8%. So the big point I'm trying to draw home right now is that colorblindness, like hemophilia is another good example. These are disorders that are passed down on the X chromosome. They are a sex-linked inheritance, order of inheritance. So a guy has one X chromosome and one Y chromosome. I did draw the Y deliberately smaller than the X because it is smaller. It actually has less genetic information than the X chromosome, right? And then a female has two X chromosomes. So one of the reasons males have a way higher rate of being colorblind is that they only have one copy of an X chromosome, right? So if this guy has a faulty X chromosome, or there's a portion that doesn't code for a protein, we won't go into it, but it won't code for a protein that's important, or it's misfolded or something. This guy has a faulty copy and is going to be colorblind, right? If he inherited that portion of the gene, about 8%. But if you look down here to female, even if this female had one bad copy, she still has a totally normal X chromosome. I mean, so she's not going to be colorblind in this example, right? But if, for this female to be colorblind, she would need to have two bad copies. And then if you were to do the math and how to figure out how many females are colorblind, it's actually not like a linear rate of like, oh, it would be half, it would be 4%. It's not. What you do is you take 8% times 8%, right? And yes, I'm rounding, you guys can figure out what that number actually is, but for the sake of illustration, that really results in approximately 0.5% of females are colorblind, which is way less than 8%. 8% is way more than 0.5%. And the reason I wanted to bring this example up is that whenever it's an X-linked disorder that's passed down, it's going to be way more common for a guy to have that disorder because a guy only gets one X chromosome and a female gets two. So you'd have to have two bad copies of an X chromosome. I mean, there's different types of genetic expression, but just for the sake of illustration, a guy has one X chromosome, so it's way more likely if he gets a bad copy, there is no backup option, right? Whereas a female has a backup X chromosome. And notice how you can kind of take a look at that mathematically, that it's way less common for a female to be colorblind than a male at 8%. So I just wanted to go over that example. Hemophilia is another good example of an X-linked sex inheritance. All right, guys, hope you like that.